Hello viewers, this is another ZVS I've built, but I've got a couple of simple tips for newbies who try to build these ZVS drivers without too much drama. First one is, first test, handy to put a 12 volt 60 watt bulb in series before applying power, just in case there is a dead short. You won't blow your MOSFETs and the lamp will take up the current, the excess current. Another thing which I found quite handy is an on-off indicator on the ZVS itself. It proves straight away if the circuit is oscillating. Whether there's an arc or not, it still works. It's just an LED, it's a blocking diode and a couple of turns, about 2 turns in 1K resistor. To have less heating, I found that the metal C-clamp, I'll just turn it off, this metal C-clamp, if that gets slipped off a little bit and the windings are put, not sure if you can see it, on the inside of the metal, there seems to be less heating because it's not part of the circuit. Of course the wires between the tank capacitor, in this case it's only a simple 560 nano, and the working coil to 5+5. Keep them as short as possible, it seems to help. Then if you have an ammeter, it's very handy. It tells you straight away what current is flowing in the circuit, in this particular circuit about 3 ampere. Then the MOSFETs themselves, they need to be rated at roughly 4 times the basic supply. So in case of a 12 volt device or power source, they need to be rated for about 50 volts. These MOSFETs are fitted on the same heatsink. One needs to be fully isolated with a bit of mica washer, and Zenas in the high speed diodes can be made very compactly. And there are the two 470s, and I got an extra 100 ohm in series here. I'll provide you a schematic. That's the inductor which sits on the positive. That's the plus coming in, blue is minus. The output is here, the 2 purple wires, they come out of the 2 MOSFETs here, go to the outer sides of the working coil, 5+5, and the center tap is basically on the center of these 2 windings. Here you got a close-up of a coil, how it's wound. Wire in, left turn in this case, 5-6 turns, comes out here, next turn, same direction of winding, and the same amount of turns, and then the wire comes out. So basically these 2 wires here are your center tap, and that's your outer in, your 2 outer taps here. So yeah, important. If you wound them opposite ways it won't work. Okay, we've got only a tiny arc here at 12 volts with the lamp in series. Now I'll bridge the lamp out and show the intensity in the arc. Comes a little bit more whiter and the copper starts to glow as well. This is just only running at 12 volts. The oscillator LED is a bit brighter at the same time as well. Now we're going to run the device on 24. Okay, I'm set up for 24. Look at the arc, how it burns. Get quite a bit of current there. The cable is flashed over. I should have used one of the insulated corona rings. Oh, yeah, the arc is a lot more violent. The current is about 6.5 ampere. Turn the light off. A lot more intense. Here, copper is almost melting. Got a bit of green in there. I'm not sure if the camera picks it off. It looks a lot better off camera anyway. Current is up to 7 ampere now. That looks quite cool. There's a lot of heat in that copper. Well, the MOSFETs are cold. Flyback is pretty cold. Oh, the capacitor is even cold, so it's not good, not bad. Schematic. Flyback, capacitor, and I hold it still here for a while. That's the basic oscillation schematic, which is clearly easily available on the internet for the Mazilli ZVS oscillator, made for 12 up to 36 volts DC. MOSFETs, the best ones are IR/FP 250s or 260. Can be obtained on the internet, often with free postage worldwide. Just after previewing the video data, this is a close-up of the coil, more or less, with the C-clip on the outside. Then the terminal at the other side of the coil, that is usually the third pin I've found. Important is to sleeve that particular piece of wire, solder it up, and I put a bit of clear tubing on it. As soon as you have a carbon track in there, because of a flashover, that is usually the end of the flyback, because the corona will form around it and cause flashovers. So that's in general the negative, and then the red wire on the other side is the positive. While stripping these things out of all TV sets, it's quite handy to keep these corona ring spacers.